if you're having a single terminal symbol, then you make a transition and you make a final state and put in there. Okay. Now left out with epsilon, sorry, A. For capital letter A, I'm having B to BB. Okay, I'm not having any BB, right? So I can use one more state like this, BB, and this is B. And from B, I can directly transfer this to. That's it. As simple as that. And then finally, one epsilon is there. And this is to the final state. Fine. This is your final NFA or finite automata for the given production rule. That's it. So if you're having any doubt, please let me know. Now, if you might be having one query, which is being built up in my mind, is S implies small letter A, capital letter A. For the production, S implies small letter A, capital letter A. When this will be accepted? Let me check. From S, A, okay, capital letter A. From A, there is an epsilon, and then definitely this is reaching to the final state. Therefore, this production is accepted. Correct? If I want to check S tends to small letter B, capital letter B, is this accepted or not? Small letter B, there is a small letter B, okay? And again, there is a small letter B to final state. Definitely, I am having a possibility where I can get small b, then capital letter B. Okay, now if I is it accepted or not, I have to check. Now if I replace this B by small letter b, then what will be the string? BB. So the initial string that will be possible is BB. So this is also accepted. So in this way you can also check it out whether this particular productions are being accepted or not. Okay, so this is your first example. You can again pause the video, or you can rewind the video, and you can check the steps one after another. Okay, let me move to another example. We'll be doing 3 examples. Okay, so now here I will try to explain in 2 different ways. One is this one. S is the initial state. I'll move a little bit fast. S is the initial state. So 0 moving to 1s, as I've told you earlier. So 0 moving to 1s. Again 1 is left out. So 1 again moving to s. S is here. So again it will be like a loop. Correct? And finally 0 is one more transition left out. Since this is a single terminal symbol, so from S, 0 will be going to a final state. That's it. Now if you want to check an initial string, if I want to check like this, S stands to 0, 1, S. In place of S, I want to put it by 0. So the answer will be 0, 1, 0. So if you want to check in the grammar whether this string is accepted in the automata, whether this string is accepted or not, first is 0, 0, okay. फिर 1, 1, okay. फिर 0, फिर 0, okay. This is the final state. So this string is accepted. Now if you want to put in S, again 0, 1, S. That means it is repeating. If you look at this diagram, this is becoming a self loop. So n number of times you are replacing by S, it will be look like a loop, and finally it will be reaching to the 0 only. So this is one way of working. And if I ask you a question that is this a epsilon NFA? No, this is simply a finite NFA, right? Now if I ask you to draw an epsilon NFA for this, as simple as that. Now how you have to draw? First you have to check how many productions you are having. Again, I'm writing over here, S tends to 0, 1, S and 0. How many productions you're having? 2 productions. So from initial state S, I'll be drawing 2 productions. One is your 0, 1, S, that is epsilon, okay? And one more I will draw as epsilon to 0. This is one kind of naming. You can also name your states later on, okay? So this is one epsilon I have drawn. Now this diagram is not yet completed. Again, the same process I have to draw. From 0, 1s, 0 is going to where? 1s, and 1 is going to s. So again, it will be acting as a self loop. Okay. Same process, 0, where it is going? It should have been gone to a final state. So I'll be drawing a final, and this will be a 0. So this is your epsilon NFA. and this is just an NFA. That's it. So these are the two examples that I am going to share with you. And in this, I haven't drawn any epsilon NFA because epsilon was already there. Okay. So these are the two examples. Please, if any doubt, pause the video, rewind it, check the steps. You will definitely understand it. It's as simple as that. And the last one that I want to give it to you is this one. So please, again, I would request you to pause the video and try on your own. Definitely will be getting the answer. Okay. But I will also give you the solution. So first I will draw a simple NFA, as simple as that. S is the initial state where it is going A. Now if I ask you for simple A, if I ask you for simple A, and this is your final state, correct? Now if I want to ask you A, where it is coming, again it is coming to the same state, so you can make a self loop as A. Again for the next production, again B is coming to the self loop, same state, so A comma B. So this is your NFA. Now if I want to ask you for epsilon NFA, how you want to draw? There are 3 productions, so for 3 productions you have to draw 3 epsilon transitions. So S, 1 epsilon transition for AS, another epsilon transition for BS, another epsilon transition for A. Now A is not yet finished, so I can draw A and I can put it into the final state. This is again coming back to the same state, so I can put it as A. Again this is coming to the same state, again I can put it as B. So this is your epsilon NFA. I think you have got the same answer, and this is your NFA. That's it. So finally we have done with these 3 numericals where you understood a conversion of a grammar to a finite automata, where you have learned NFA conversion and epsilon NFA conversion. Okay. So finally, I want to thank all of you for listening to this video, where we have learned all the 3 topics about types of grammar in terms of linear grammar and derivations, types of derivation tree, where left derivation tree and right derivation tree you have understood. I have also brushed you up with ambiguous grammar again. And last, we have discussed the conversion of a grammar to finite automata. My suggestion to you is that please follow a book for automata theory and formal languages. I would suggest for referring KLP Mishra. And also you can also, if you are reading any Indian author book, then Adesh K. Pandey is also good. Yeah, KLP Mishra is an also Indian writer, but yes, his way of writing the book is very good in terms of theoretical, in terms of practical, in terms of numerical. Okay, and his content is very good. But if you talk about number of questions, number of practice questions, I would suggest Adesh K. Pandey is a good book, and you can follow that. And definitely by the end of your as I've already promised you, by the end of your lecture videos, I will give you 25 to 30 questions, which I will ask you to solve it, and definitely with solutions. Thank you. Have a nice day.